My name's Owein Reese. I work at Media Math. We're going to be sponsoring the drink and food later on. I'm here to talk about dependent types, mostly because I see a lot of libraries coming out that don't use them. People really aren't sure about what they are, and I'd like to give like a little introduction and just show like how you can actually use these things without being scared about them. So before I even get in like the context of what this is what I mean by path-dependent types or dependent types in terms of Scala. So if you actually take a look, there's really just a trait or an abstract class that you have up there with this abstract type parameter. And if you pass it into a function, that function, the return value actually depends upon the variable that you passed in. So it becomes very context sensitive. And when you start using these things with implicits and sort of type classes, you can start really doing some magical things at the type level that can really simplify your life. Or if you want to go really crazy and be some sort of type astronaut, you can really complicate your life. So one of my favorite children's books has got to be Through the Looking Glass. And one of the things that I like about it and what's so entertaining is that the author decided to take a lot of the rules that people are used to and just throw them out. I mean, not completely, like not where it was absurd, but like, you lose your head, that's bad. Everybody remembers that off with their head. But sort of the kinds of things that you see that you wouldn't expect, but if someone says, oh, this is my perspective, you're like, okay, well, I can see why the way I feel is rather absurd. So let's say that I want to go through and I want to start doing some of this stuff in Scala itself. And I'm going to come out and I'm going to make this list ops, this thing that's based upon lists that, some more sort of pimp my method or whatever. And I want to come out with this flat size and I write it like this. Well, if I try and compile, the first thing I'm going to see is I'm going to get this exception. It's going to be saying like, hey, there's no implicit, there's nothing that tells me or tells the compiler that this type of A that was in list is itself a traversable. In other words, it can be flattened. And we can see this comes directly from the flatten method on list. And a lot of people, when they see this, they don't even realize that, first of all, that flatten actually has a type parameter, because when they're working with it, a lot of times they think, well, list of t, the type parameter is t, but in fact, the type parameter is list of t. And you need to tell the compiler, like, this abstract type t needs to be flattenable. So if I write out the full signature and I take a look at what this really looks like, I have flat size with this implicit, but oddly enough, I get this weird type parameter b up there. I mean, this thing just sort of floats there. I'm not really using this type parameter. I don't need it. It doesn't really add to my understanding of what flat size should be, but it sort of happens because of this implicit. And that's really a shame. That's kind of bad, because these sort of types that you have and these methods start bleeding up to other calls, and you get what I would call type pollution. Types that really are there but you don't care about. So if I were to rewrite this and I were to come along and to have done this, I'd actually use this is traversable once. And I'd come out and it looks almost exactly the same, except that it's using dependent types as the type to return. In other words, it uses this thing that's actually found in Scala itself that has this abstract type A that is the type of the traversable which comes out. So I mean, here I only have the type that I care about, and if I actually want to get to that list and I want to use the types within it, well, there it is for when I want it. So my new signature, if I were to have flattened written like that, and I were to come out and I were to use it, well, that B actually disappears. And now my types are actually telling me exactly what I want it to be. This flat size returns an int. I don't care about anything else. Here's my list of A. There's my is traversable once, and it only depends on A because that's all that's important. It's just saying A is what's traversable. And this sort of pattern, this type of thing is probably, if you were to ever start using dependent types and putting them into your libraries and using them to effect, this is what it is. It's really a sort of a compiled time type reification. In other words, this is just identity the way I've defined it. I say it's some type and I'm passing MA into the apply and I get MA out. And the compiler's often smart enough, once it's been running enough times, to say, well, this isn't really doing anything. I can get rid of this. But at the compile time level, you're actually saying that this abstract type A is a type. It's got this some type. If it was a list, it could come out and say like, okay, you actually have use of map or flat map or filter of all the other methods that would be on list. If it was just some abstract type A, you sort of would use that. And that becomes a very powerful sort of mechanism for implicit guards and things of that nature. Of course, flatten's kind of like a trivial example that I just sort of pulled out because nobody uses it. I mean, how many of you have actually used flatten itself like every single day of code? One hand came up. Once a week? Once a month? Once a month. Okay, so yeah, why? That's because we have this wonderful method called flat map. Flat map came out because of this stuff, because nobody wants to deal with sum of none. That's kind of like taking a cardboard box that's empty, wrapping it up, and giving it to a 4-year-old for their birthday present. You know, like, this is terrible. I mean, there's true, false, and file not found, or something like that. I mean, just no, don't do that. But the thing is flat map requires you to preempt it. Like, you yourself have to know. So during code reviews, you're going to catch people going, did you mean to flat map that? Oh, yeah, of course. A more intuitive way would be sort of less mistake prone, as if map itself said, nope, I'm only going to work on things that can't be flat mapped. And flat map said, well, I'm only going to work on things that can be flat mapped. But this really isn't far enough as what I'd like to see, or to push it this far. So I really don't want to think about this stuff. Like, honestly, I don't care, map, flat map, whatever. It should just happen automatically. So if I were to make it happen automatically, this auto magic way is, I'd actually write map or flat map in terms of something like this. And I could actually get rid of map and flat map if it weren't for the, for comprehension syntactic sugar, in terms of this sort of dmap function, this sort of dependent map function. I take a function t to b, some implicit that depends on b, a type class there, and I get out my type, my m. And to say this or talk about this in sort of an abstract term is not really helpful. So I'm going to actually talk about this in terms of something like a continuation monad, because this is probably an also rather unloved monad. Here you have map, you have flat map. I mean, apply is just t to r that returns an r. So the map self, you see f and then g, that's a t to r. And then you see down in flat map f of a t and put in g into a continuation of b of r. Well, that's just t to r. And it's lovely and it composes and it works great. So if I were to rewrite this in terms of this dmap, well, it kind of looks slightly different. So the apply that I would have out sort of very similar looks like what I have in map and flat map before of this past continuation. But now it's in terms of this tie thing that takes in the function of f of the dmap and the parameter g, that's this function that comes in. And it's based on some weird, crazy abstract type parameter. And this apply just comes in and it returns an r, which is exactly what the continuation says it needs to return. But other than that, it's not really providing as much context as you might think. So to actually make this tie, to have it come out and see, and by the way, this is going to be the most complicated slide. Can everybody see the code? Yes? All right, good. I'd actually define it in this term. So first of all, I'll take a step back and I'll say, like, look, I'm going to do a little hand waving here on this aux parameter. There's a talk that New York Scala guys you probably have seen if you attended it. Next month I'll be coming up here, Boston, to give a dependent type talk that I'll go really in depth on. The rest of you, I can probably talk to you later on about it. But what's going on here is actually type level pattern matching. And this is sort of like the most advanced kind of weird-ass crazy stuff that you might put up on the type level. But what you're doing is you're having this object tie that extends low priority tie. And you see two different implicits here. So I'm using implicit resolution order to sort of sort of program in like how to do this pattern matching and say like this implicit here takes priority of this implicit. The next thing I have is this apply that has these two parameters C of R that is an implicit of tie that returns this aux thing. What this is doing is actually is I'm allowed to shove anything I want in these objects and these traits, and I can just say import tie instead of import tie dot underscore. And what happens is I can not pollute the rest of my code base with implicits or weird stuff that might happen. It's all going to be kept compartmentalized in here. That apply itself, when Scala starts trying to take a look for a tie of type C to R, we'll hit that apply, hit that implicit if it can be done, and return that tie. And that's how it sort of gets it. It's this escape hatch or like hole into this weird universe you might construct. This aux is, that's to help the compiler do type inferencing. I won't get into it, but if you don't have that, it starts losing track of what the types are, the dependent types. It'll compile and say, okay, these are the right types, but then you go to use them and it has no idea what type it is. So this implicit, this tie FM, I mean, essentially what you see here is a continuation of B and R, and it's just taking in a continuation and putting the function in like you would. I mean, this is exactly the same case as flat map. And this low priority, if you take a look at this is taking anything that isn't continuation, or, well, it would take a continuation if you let it, and running it through much like you would map. So obviously the name is TieFM or TieM. And if I take a look at this a little more closely, or see this in sort of the context of DMAP, these applies of tie here, this one coming in, this is flat map. I mean, and this is map. And the fact of the matter is I myself don't have to call whether it's coming out as map or flat map. The types themselves will actually call into scope the correct tie, and the tie itself will actually do the map or the flat map. And that's it. I don't have to think about it. It just sort of will work. And I think this is probably half the time what people would want. I mean, I don't know about you, but I've never actually written a list of some T and gone, yes, this is the type parameter I want. I want lists of lists. Yes, absolutely. No. But as helpful and as useful as that might be, that isn't always like the be-all, end-all. I mean, sure, I could see people come through and be like, I want a state monad of a state monad of a state monad, maybe. Or they'd be like, well, you have a state monad transform or something. But sometimes we wouldn't think about where maps or flat maps might actually be used or might want to be used or maybe should be used. So I see a lot of methods like this, and you probably have done this in your library. You've written code like this. You've been like, well, I'm going out to some database or some API somewhere, and I don't want to have this blocking code. So this call, this A type may actually be some like result set, JDBC result set, or something like that comes back. I want to map over it with this function, and I want to do this in a synchronous manner. And we think, wow, I've done something really great. This is good. This is the way we want our code to be. No, you don't. And that's because you can get these two things. The first one happens by accident. You might have a method that is synchronous, and then later on, as you are enhancing the code and different functionality comes out, someone says, well, this actually needs to be asynchronous, and he goes through and he makes sure everything compiles. And then, as most of you probably do, because I know we do a lot, you only code review the diffs, all the places people have checked. And because this is returning a unit, I mean, it's a side effect, nobody cares. They probably don't even look at the return type of this. The function that would produce this probably returns unit itself. The second one is arguably much, much worse on a conceptual level. And it's funny, someone was asking Bill like how to work with future and or. I'm gonna show one way of potentially do that. And here's Here's why future of try is really, really bad. Look at that third case. That says, congratulations, you failed. That's no kid to his parent when he's showing his report card. Guess what? It came in, I failed. You're not going to do that. Even worse is your on failure is sort of missing half the failure cases, and your on success has to handle failure, which is really horrendously bad. So you have a future which has success or fail. You have try, which has success or fail. You may have other things that have this sort of concept of success or fail coming in. So I'd actually rewrite it something like this. By the way, this tie and knot and stuff like that, I was looking at bind, and I was thinking, okay, what's sort of similar? I mean, you can bind ropes and stuff, so you can tie ropes or you can knot them and that sort of thing. So I'd actually look at this and just knot. Awesome, great. So if you come out with something like this, and you sort of structure your code like this, by the way, this forces you to do something. So it forces you to separate your synchronous code from what you would do with the result of that asynchronous code, which I quite like. And if you were to actually show the implementation, it's not going to be that much different than what we were doing with DMAP, where again, we're doing sort of pattern matching at the type level here, but we're doing the first case, a future, and you're just going to flat map. So what this would do is if your function itself will return a future and you'd get a future of B, well, what you actually get is just a future of B. And the second case is if you would get a future of try of B, you just get a future of B, and that's it. I'm just taking flat mapping as much as I can. I've left off the low priority because, well, that's pretty straightforward. It's just map. And if you were to think about this in the context of what was going on up here, you see that this knot, this knot.r is actually, it's pulling out, it's sort of piecing out and pulling out the type parameters that would be in our nested future or our nested try, so that I don't ever have to think about this. I don't have to handle it, or I don't have to do anything with it. It yeah, just sort of pull this stuff out. Wow. I really raced through this. All right, but I raced through this because I know there's going to be a lot of questions generally when I do this stuff. So who's got questions? Who wants me to go back and start going over stuff way in the back?
So can be pretty gnarly. So is that what Ox is about, or like how do you just manage that?
All right, so yeah, all right. I'll go. I guess I'll go through that because we definitely have time. Yeah, Ox is definitely about that. So one of the big problems is, of course, as you say, type inferencing. If you were to take a look at like this apply, the way it's defined, and I'm returning this tie, and you think about how this is defined itself, the actual type, if you think about it in type inferencing, is going to say, well, this is some type of B of R with an abstract type. And I look down here, and I see, like, without that aux going on, and I'll tell you exactly how that aux is working, it's going to say that's some type with some abstract type. So even though you could look at the value of it, and the value would be consistent with what you expect, the type's lost. So this type parameter, the way I've done here, the way it's defined is very specific and sort of critical to this type of like, hey, compiler, by the way, this is what you need to know. This is, if you want to think about it in mathematical terms, like the way this is defined is it works this way and it works this way. In other words, it's one-to-one and it's onto, or it's, they're an inverse or an alias of each other. And this is saying, like, by the way, this third parameter is my dependent type. And if I define it that way, the compiler knows, okay, this is the type it must be. It will actually do a type check if you try and put something in and define it and say, like, whether this is or isn't the type you expect. The weird thing is the way that aux is defined way up there, it's kind of like recursively defined in the type that I'm actually going to lose, which is kind of odd. But somehow it actually works. This parameter here, tie, when it goes tie.in, the compiler will actually keep that type parameter right up until there. After that, it'll lose it unless I do this. It just says, well, I know right up to that point, and now I've forgotten it. I don't know why. It just, poof, gone. So you do these sort of awks that you'll see in some of the libraries that use these dependent types, so that that type keeps going through and propagates at each step along the way. Does that answer your question? Anyone else? Yes.
Do you have any like REPL examples, like you saw in earlier talks, that show what's inferred from those?
Do I have? Yeah, I could actually show you something from my other talk, but what it'll tell you is it'll actually say this. It'll say tie cr pound in. That's it. That's your type. Like, it's some type abstract in. Awesome. It won't actually say, like, this is an int or this is a double. Another hint? And I can show you afterwards, by the way. I have no problem. Any other talks? All right, questions? Yes? No? Wow. Okay, I got done really quick. Sorry about that.